Okay, there's nothing wrong with doing this over here. I'm gonna write this down for you. X squared, 2x squared. If you complete the square nut, you'd add 1. But I have 25 there, so it's supposed to be 24. That would equal 0. This is a perfect square. What he left off with, x, I'm sorry, it's x4. X squared plus 1, quantity squared plus 24. I want to point out, if you proceed forward in this, though, you're going to get a nested a nested root with a complex number. So I kind of want to avoid that. And so what I want to do is a little bit different, the way that certainly Wells would suggest you do it. But this is fine. You did this. You could certainly factor that. But again, you have a complex number right from the get-go. You're going to use a quadratic formula. It's going to be there's going to be a complex number within a root. And although we can unnest it, it seems like a lot of work. It'll lead to the same answer, though. So what I want to do is a little bit different. So I'm going to look at this over here, and I'm looking at not the middle term, I'm looking at the end term now. So x4 and a 25. And what would the middle term have to be? Well, it's going to be 2 times 1 times 5, which would be 10. 10 what? 10x squared. But you know, I have 2x squared, so I have to subtract away 8x squared. And that's equal. All right, it's equal to what's written over here. No different between the two. What's the advantage of this one over here? Well, I got a perfect square. That's x squared plus 5 and minus 8x squared. Well, I'm going to put the factorization down now. What's it going to be? Let's see, x squared plus 5 minus, well, let's see, that's going to be root 8x, and then x squared plus 5 plus root 8x equals 0. I'm going to write them a little bit differently. I'm going to write as x squared minus the root of 8x plus 5, and this was going to be x squared plus the root of 8x plus 5 equals 0. I'm going to use a quadratic formula on those two, and one at a time. I'll take this one first. Whoops, I didn't mean to do that. I'll take this one first. And what's x going to be equal to? Let's write this down. X will equal, let's see, twice the coefficient on the square term. Let's see, then it's going to be root 8 plus or minus. You're going to get 8 minus 4 times a times c. Well, that's going to be 20. What do you get over here? X equals root 8 plus or minus. This is 2. That's going to be minus 12 on the inside there. And what are you going to get there? Well, you're going to get 2i root 3. Time for me to do some reductions over here. I want to claim, though, that probably I shouldn't be writing root 8 down now because I need to reduce. It's going to be 2 root 2. So what do you get? X equals root 2 plus or minus I root 3. All right? So that's one answer. Let's do the other one. And let's do this one now. That's really not going to be that bad. 2 minus root 8 plus or minus, well, let's see, 8 minus 4ac minus 20. I think you're probably saying deja vu all over again. Minus root 8 is minus 2 root 2. And we just did this before, so plus or minus 2i root 3 over 2. You do your reduction, you're going to get minus root 2 plus or minus I root 3. Again, it's a fourth degree polynomial. I'm expecting to come up with 4 separate solutions, and I have them. Furthermore, it's a real coefficient polynomial, and I expect my complex numbers to occur in conjugate pairs, and I clearly see that. All right? So let's get the answer and see if we got it right. Am I seeing this? Let's see. Right here. Am I seeing this? Right here. All right. We're good to go. Thank you.